Hello friends, how are you? I hope you are enjoying. Today we are going to learn about transformers, thermal power plant. A transformer is a device that transfers electrical energy from one electric circuit to another electrical circuit. A transformer is a static device or equipment used either for raising or lowering the voltage of an AC supply with a corresponding decrease or increase in current. It essentially consists of two windings, primary and secondary, wound on a common laminated magnetic core. Now let us see the major parts of transformer. Windings. Depending upon the manner in which the primary and secondary windings are placed on the core and the shape of the core, there are two types of transformers called core type and shell type. In core type transformers, the windings are placed in the form of concentric cylindrical coils placed around the vertical limbs of the core. The lower voltage as well as the high voltage winding are made into halves and placed on two limbs of core. The LV winding is placed next to the core for economy in insulation cost. Conductor material used for windings is mostly copper. However, for small distribution transformer, aluminum is used. In the shell type transformer, the primary and secondary windings are wound over the central limb of a three-limb. The HV and LV windings split into a number of sections. The sections are interleaved or sandwiched. It is a section of the HV and LV windings are placed alternatively. Core. Core is built up in CRGO, cold rolled grain oriented steel laminations insulated from each other. This helps in reducing the eddy current losses in the core and also helps in construction of transformer. Tank and conservator. The transformer tank contains core wound with windings and the insulating oil. In large transformers, small expansion tanks connected with main tank is known as conservator. Conservator provide space and insulating oil expands due to heating. The pressure vacuum gauge indicates whether the gas space in the tank is under positive or negative pressure. The pressure will vary depending on the transformer temperature. Some additional devices like breather and Buchholz relay are connected with main tank. Buchholz relay is placed between main tank and conservator. It helps the transformer under extreme heating of transformer winding. Breather protects the insulating oil from moisture when the cool transformer sucks air inside. The silica gel filled breather absorbs moisture when air enters the tank. Bushings will function as an insulator between transformer tank and windings. LV winding is taken out as LV bushing and HV bushing is taken out as HV bushing. Principle of operation. When an alternating voltage V1 is applied to the primary, an alternating flux is set up in the core. This alternating flux links both the windings and induces EMFs, primary EMF E1 and secondary EMF E2 in them according to Faraday's law of electromagnetic induction. If load is connected across the secondary winding, the secondary EMF E2 will cause a current I2 to flow through the load. Thus the transformer enables us to transfer AC power from one circuit to another with a change in voltage level. Note that the magnitudes of E2 and E1 depend upon the number of turns on the secondary N2 and primary N1 respectively. If N2 is greater than N1, then E2 is greater than E1 or V2 is greater than V1 and we get a step-up transformer. If N2 is less than N1, then E2 will be less than E1 or V2 will be less than V1 and we get a step-down transformer. Now, let us see where transformers are used in thermal power plant. Based on the location and usage, transformers are named in thermal power plant. Most important is the generator transformer, which is receiving power from generator. This is the highest capacity transformer inside whole thermal power plant. After that, there are transformers for sending power to grid at higher voltages, or sometimes station transformers. And there are some transformers used for auxiliary requirement of thermal power plant, which receives supply from generator transformers, sometimes called auxiliary transformer. Substation auto transformers transfer the incoming high voltage to the next lower voltage level. Like incoming high voltage of 220 kV would be transferred down to 130 kV. Hence, generally used when two different voltage rated buses are there in switchyard. Other than that, for big systems, we have separate transformers like for cooling tower, electrostatic precipitator, ash handling, etc. Separate transformers are used. From generator transformer, power flows to unit auxiliary transformers and it is fed high voltage systems or step down to low voltage systems or LT systems using step down transformers. In LT systems, small motors like used for pole stacking, station lightings, etc. are connected. Hope you enjoyed the video.